When we shoot an arrow from the bow, we observe that it hits the target. But if we throw the same arrow without using the bow, then it does not pierce the same target. Do you know why the distance traveled by the arrow in the two cases is different? It is because the energy possessed by the arrow in the two cases is different. In the first case, the arrow possessed more speed and thus more energy, so it covered more distance and was able to pierce into the target. While in the second case, the speed of the arrow and thereby the energy of the arrow was less, and so it could not travel sufficient distance to pierce the target. The energy possessed by a body by virtue of its motion is known as the kinetic energy of the body. The word kinetic is derived from Greek word kinetikos, which means to move. Ideally, a stationary body possesses no kinetic energy. The SI unit of kinetic energy is joule. The formula to calculate kinetic energy is half mv square. The amount of kinetic energy of an object depends on the mass of the object m and its velocity v. To demonstrate the dependency of mass on kinetic energy, consider an empty truck with mass m1 and a loaded truck with mass m2 moving with the constant velocity v. Let both of them hit into the brick wall marked A and B respectively. Impact on the walls is equal to the work done by the moving body. The empty truck breaks the wall A partially, while the large truck demolishes the wall B completely. The kinetic energy of an object is directly proportional to its mass. This means when mass is double, the kinetic energy is double for the same velocity. Similarly, consider two cars with the same mass m hit a wall with different velocity v1 and v2. The slow-moving car cracks the wall, while the fast-moving car makes a hole in the wall. The kinetic energy of an object is proportional to its velocity squared. This means when velocity is double, the kinetic energy becomes 4 times with the same mass. Kinetic energy is possessed by all the moving objects in the universe, including a crawling snail, a shooting rocket, and the rotating earth, and so on.